This is the new CaddX Avatar HD repeater module. Now, if you don't know what this is, it is a device that will relay your signal from your VTX to your goggles. The idea of using a device like this is to allow you to either fly further than you normally would be able to with the standard setup by either positioning this at a higher elevation or alternatively positioning it at, say, a midpoint, or alternatively, you can use a device like this when positioned correctly to allow you to maintain flight without visual line of sight, because you can have your quad communicate with this, your goggles communicate like this, and position this where it still is able to see both devices, but it means your goggles don't necessarily have to be able to communicate with the quad. Now, in this video, what we're going to do is give you an overview of this device. We're going to talk about what it can do, what it can't do. We're going to take a look at the latency penalty as a result of using this device. And then at the very end, I will demonstrate this in a scenario where it will allow you to maintain visual line of sight. What I'm not going to do in this video, though, is demonstrate the kind of range improvements that you could get from a device like this. That is not something I can do here in the UK, but we can absolutely demonstrate that it works by allowing us to continue to fly without the goggles communicating with the quad itself. Now, just before you get into this, I just want to say this was sent to me by CaddX for free. However, they have not paid me to make this video. They've not seen this video before it's been published. They've not sponsored this video. And as always, my thoughts are entirely my own. Okay, so let's take a look at the device first, and then we'll come back and talk about some of the quirks and the things that you need to be aware of. So, in the box, you get a little setup card from CaddX, which is nice to see. We have the module itself, which is here. Not that large. We'll weigh it and stuff a little bit later. But what you can see is you've got the module. You've got two sides to it. So you've got this side here, and that says 5.1 to 5.3 gigahertz antenna linked to the VRX. And this side, 5.5 to 5.8. antenna linked to the VTX. Now, from that, you can already see there is a frequency shift going on, and we'll talk about that a bit more in a minute. We've then got our antenna connections down here, which is good to see. We then have antennas included with this kit. So there are 4 antennas on each side. Now, these are patch antennas. So there are 4 5.15 to 5.3 gig patches. And then there are also another 4 5.5 to 5.8 gigahertz patches. We then, in the bottom of the box, also have our cables. So what we have included is a USB cable, and I'm guessing these are power cables. Okay, we'll have a look at them in a minute when we look over the module. Now, looking at the module in a bit more detail, it comes in an aluminium housing. There's this sort of holes here for the fan, although it's in a, looks to be a bit of a pretty pattern. We've got our antenna connections on each side. So there's 4 on each side. These are SMAs. They are not RP SMAs. They do include the antennas as I've shown, but do take into account that they are standard SMA fittings. Now, looking on this side of the module, you'll find there's a USB port. There is a bind button and a light for the VTX side, a bind button and a light for the VRX side. If we spin it over to this side, we can find our power input. You can see there, it takes 9 to 26 volts, and it uses these connections here. And then there's a tripod mount there. Now, there is nothing else externally on this other than there is some labeling here as well for the frequency of each side. And when it comes to setting up, you simply need to plug in the power, connect the antennas, and bind it to your system. Now, with regards to the size and weight of this unit, if we look at its length on my ruler, it is coming in at 10.5 centimeters roughly, or for our Stone Age friends, it is 4.25 inches by 7.25 centimeters, or just under 3 inches, 2 3/4 inches, and its depth is 3/4 of an inch, or in the modern world, 18 mil roughly. With regards to weight, we'll take a look at it on my scale. So if you did want to mount this on an aircraft, it is going to give you a payload of about 142 grams without the antennas. If we dump all of that on top as well, which isn't as easy as it looks because they all want to fall off, you're coming in at about 240 grams. Now, when it comes to the antennas on this, they are basically identical apart from their frequency range, so you need to make sure that you get the correct ones on the correct side. So this side is the 5.5 to 5.8, and this side is the 5.1s to 5.3s. They are directional patch antennas, so you do need to take that into account. They do need to be pointing towards whatever device you are going to be using this. So one side is going to need to point towards your VTX, one side is going to need to point towards your goggles, and we'll talk about that a bit more in our actual testing. With regards though to the antennas themselves, you do need to just be careful when you mount them. You're going to need to spay them out a little bit, or you're going to need to point them in different directions a little bit. I do need to do some testing on this, which I haven't done yet, on which of these antennas transmits and which of these antennas receives, because on the typical Avatar HD system, on their receiving side, so their goggles or the VRXs, you have one transmission port and 3 receive ports. I believe that's the case here as well from the information I've seen, but we're going to need to test that on the analyzer to confirm which one it is. Now, the way this module actually works is that it sits between your goggles and your aircraft for communication. It doesn't just pick up a signal and repeat it. You actually have to bind your goggles to the repeater module and your aircraft to the repeater module, and then your signal from the aircraft is relayed via the repeater to the goggles. The signal from the goggles is relayed via the repeater to the aircraft. When you use this, you break the link between the goggles and the aircraft directly, and all communication has to go through the new repeater module. The way it actually works technically is that the aircraft side communicates with this module on 5.8 gigahertz as it used to communicate with your goggles. However, on the goggles side, it actually changes that frequency from 5.8 gigs down to 5.1, and that is why you have different antennas on one side. So the goggles communicate with the module on 5.1, 5.2 gigs, and the aircraft communicates with the module on 5.6 to 5.9 gigs. This allows the two signals to remain separate, and it relays them between them. As a result of this though, as I've mentioned earlier, you no longer have the direct communication when using this module between the goggles and the aircraft, and that means both of these devices must always be within line of sight of this module. What you can't do is just send this module out and then communicate directly with these two and then hand over to this at a certain point in the flight. At all times, the goggles and the aircraft must be able to communicate with this module. As an example of that, if you place this module, say, 100 meters away from you on a field, and you had your goggles and your aircraft next to you, you would actually have your signal from your goggles going 100 meters to the module, then from the module, 100 meters back to the aircraft, from the aircraft, 100 meters out to the module, back to the goggles. So even though the goggles and the aircraft could be next to you, the signal must be repeated from the module, and as a result of that, the module must always remain within line of sight of these two devices. With regards to what signals this system repeats, it is only the Avatar HD system. It does not repeat any RC control links. There is no control link built into Avatar HD like DJI. It is only going to relay the signal from the aircraft and the goggles. You are going to need to come up with your own solution if you do need to relay your command and control signal. There are options out there, I believe, for the likes of Express, LRS and Crossfire, or you're going to need to fly autonomously, but you will need to take into account what you do with your RC control link, because this is only going to handle the live video feed. Now, there are a few other quirks that you need to be aware of before you can use this module. For instance, it does work with the Goggles X, the original goggles, and all of the Avatar Air units. However, it doesn't work on all of the modes. So for instance, the repeater does not support the 50 megabits a second high bitrate mode. It does not support share mode, and it also does not support the head tracking features or the race modes that were recently added into the Avatar HD system. Also, there is another quirk that you need to be aware of when using this with your goggles or your VRX, and that is with regards to the antennas. Because whilst I mentioned earlier the system changes the frequency, that is the frequency used between the goggles and the repeater. And as a result of that, you are going to need new antennas for your goggles. As I showed, the antennas on the VTX side are for the 5.5 to 5.85 gigahertz band. Your aircraft side remains on the same frequency band as it did before, but when using the relay, it drops the communication between the relay and the goggles down to this 5.1 to 5.3 gigahertz band, and they include antennas with it for that band for the module, but there are no antennas included for your goggles. The antennas that you have on your original Avatar goggles, your VRX or the Goggles X, are designed for 5.8 gigs, and as a result of that, you are going to need to source your own 5.1 to 5.3 gigahertz compatible antennas for the goggles. Now, I do believe CaddX are going to release some antennas for this in the future, but I was not sent a set with this module, and this is something that you're going to need to check before you use this. Finding antennas in that frequency band is not easy, so it is something you're going to have to check before you actually dive into doing this. Just a couple of other final notes on this before we set it up. There is no HDMI output on this, so you can't connect this to a monitor or use it as a receiver like the VRX module. And also, there is no DVR built into this either. The DVR remains in your goggles or your ear side as it was before. There is no in-between or midpoint DVR by having this in the system. Now, obviously, one of the big questions people will have is, who is this device for? What are the use cases? Now, as I said at the start of the video, a couple of them are very long flights, so you want to be able to fly longer distance than you could on the system as standard. To be able to do that, you could mount this, say, onto another aircraft, something like a Mavic or something like that, and have it flying either at a midpoint or have it flying at a higher altitude, just giving you a better relay of the signal. Another scenario might be to allow you to fly without maintaining visual line of sight. So for instance, if you wanted to be able to fly around in a building, in a structure where you're having problems with the Avatar HD system in normal use, you could position this as such that it is at a midpoint that would allow you to get to the part of the building that you need to. There are also people who may be interested in this as a sort of relay ground station option. So if you're someone maybe in a wheelchair or you're someone who needs to fly from a vehicle, you could have this on a tripod outside the vehicle or at a higher elevation, and then use that to your goggles to allow you to get better performance than you may get in your normal scenario. The basics are, it can be used for whatever you want it to, but you just need to take into account the limitations that I've mentioned. That is, A, it only relays the video signal, and B, when you're using this, this must always be within visual line of sight of the goggles and the aircraft. Now, as I mentioned earlier, this relay doesn't have an RC pass-through, and as a result of that, you're going to need to come up with your own solution. Now, I'm not going to cover that too much in this video, but I have made a repeater for Express LRS. I have already released a video on how to do this. There will not be any more coverage of this in this video, but if you're interested in seeing that, there will be a link to it in the description. This basically allows me to relay the signal from Express LRS from 868-900 to 2.4 gigs, again allowing me to do the same thing that we do with the Avatar relay. Okay, now when it comes to getting all of this connected, the first thing you need to do is make sure you update the version of firmware that is on your goggles to the latest current version. At the point of me recording this video, that is version 38.48.8. Now, whilst in the manual for this it does say 48.9, it does work with 48.8 as well. Once you have updated that firmware, you will also then need to make sure that you enable the relay mode via a text file on the SD card. Now, to do this, you simply create a text file as per the instructions. In the text file, you write the word relay equals on. You save the text file with the specific name and place that on the SD card. Once you've done that, that will enable the relay mode on the goggles. Okay, now to switch into relay mode, you need to go into settings, you need to go down to device, and you now need to go down to switch mode. Under here, you will find a new option has been added called relay. Before, you only had standard and race, whereas now you have the relay option as well. You select that, and then it will restart the goggles and put it into the main relay mode. With regards to the drone itself on the VTX side, I'm actually using older firmware on this and it binds absolutely fine. It doesn't appear that the drone firmware is so critical as the goggles. You need the goggles firmware to allow it to go into that new 5.1 to 5.3 gigahertz mode, but I have tested it with older drone side firmware and it's fine. But you should update all parts of your system to the latest. Now, CaddX have recently just released firmware version 38.4312 beta. This is the firmware that is available at the point of me recording this video. This is the one that you should use with the repeater. As I mentioned earlier, it does work on 38.43.8 and the manual says use 33.48.9, which never actually released. However, 38.43.12 is the latest version at the point of me recording, so that would be the one to use. There isn't actually new firmware for the repeater itself. It is only for your goggles and your ear side. Once that's all done, you then simply need to bind your goggles to the VRX side and your drone to the VTX side. So what we're going to do is press the bind button on my goggles and press the bind button on the VRX. And you can now see that that's bound and it's connected. And then on the drone, we're going to do the same. I have actually already done this once, so it will connect straight away because I have already bound it. At the moment, you can see it's flashing green, but in a second, it will kick into solid green there. But it's exactly the same process. So what I will do is put the drone side back into binding mode. So I've just pressed that. We will then press the VTX button and then it's simply bound. You can see we have two solid green lights. And if we now look through the goggles, can't easily show you there, but I have video coming through from the quad. Once that is done and everything is bound, you should then see your image come up. And in the bottom right corner, you can now see we've got two signal bars. We have our CHP and we have our channel 2, which is our CHP, which is our from goggles to relay, and channel 2, relay to ear side. Now, if we go into the settings, the next thing you'll see is that we now have the channel settings for our goggles to communicate with our relay. So you can see here our goggles are able to communicate on 5.15 to 5.330 gigahertz. Now, as I've said earlier, unfortunately, I'm only using the standard antennas on this, but that is the operating mode there. We then now have relay channels, and this is where you set the channels from the relay to the aircraft. So again, this is on our same usual band that you have in Avatar HD. Now, with regards to settings, there are also some additional options now. So for instance, you've got your VTX power available under here, which is limited compared to what it is in standard operation. So we've got 200 milliwatts, 500, 700 and 1000. And then if I go to the bottom corner, you've got your relay power, which gives you your power output for 200, 500, 700 and 1000 as well. Now, there are also some other limitations around this. So whilst you can set high and low frame rate modes, you cannot change your bit rate. You can see over there, it is fixed. There is no 50 megabits a second available with the relay. You are limited to 25. Now, that is the main settings and options that are available on it. You've basically got channels, you've basically got power settings, but something I will say is there are a few things you need to be aware of with the power settings, which I'll talk about a bit more after I did my RF testing. Now, in my teardown of this module, I actually spotted something interesting, and since then I've done all of my RF testing, and there is a few interesting things that you need to be aware of with regards to the RF behavior on this relay. Now, for those who have seen my previous deep dives on the likes of the Avatar goggles and the system, you will know that I've talked about in the past that the goggles only transmit the uplink signal from one antenna. All 4 antennas on the goggles are capable of receiving, but it is just a single antenna, and it is this one here on the Goggles X, that will transmit the telemetry link back up to the drone itself from the goggles. Now, this is a bit different to DJI because this isn't multi-in, multi-out. This is single in, multi-out. It isn't clear what effect this really has on real-world performance of the system. Early DJI systems used to use this kind of setup. The current systems transmit on 2 antennas rather than just 1, but I don't necessarily think this is a major issue, but it is something that you need to be aware of. With regards to this though, and this module, there's also some quirks around this as well, because this module obviously relays the signal from your goggles to your drone and the drone to the goggles, but there is differences on how each side of this module performs. For instance, your goggles transmit from one antenna a 10 megahertz signal which can be picked up from any of the 4 antennas on the 5.2 gigahertz side. That is then passed along through the module and transmitted out to the drone. That transmission on this side is only sent from one antenna, and it is this antenna here, the second port down as you see it with the tripod mount at the bottom. With regards to the video feed from your drone, that is transmitted and it is picked up by any of the 4 antennas on this side. It is then relayed through the module, changed out to 5.2 gigahertz and transmitted back down to your goggles. However, it is not transmitted out on just one antenna. It is actually transmitted out on 2 antennas. It is these bottom 2 ports here. These both transmit the signal from the module back to the goggles. The basics of this module is all 8 antennas can receive. On the 5.8 gig side, there is only 1 transmission antenna for the goggles uplink, which is the second port down. And on the 5.2 gig side, which is the transmission for the video back to the goggles, there are 2 antennas that transmit, and it is these bottom 2 here. Now, this is interesting because this is the first time we've seen a module like this dual transmit. It's only been the VTXs from CaddX that have dual transmitted in the past, but the basics are it's giving you 2 transmissions down to the goggles for the videos and a single transmission up to the air side. There is also another quirk that I spotted in my RF testing, and that is with regards to the RF power on this module. There are settings available in the menu that allow you to set it at 200 milliwatts, 500, 700 or 1000 milliwatts. Those settings do adjust the RF power output for the downlink to the goggles. However, in my tests, the uplink for the telemetry from this module to the drone does not change with the RF power setting. It is only the downlink power from the 2 antennas to the goggles that's affected. Now, I don't know if this is a bug or if it's intentional. I'm going to be honest, I don't particularly think it's a problem. I can't really say what the RF power is like. It looks okay. I can't give you an exact measurement. I don't particularly think it's too much of an issue because the uplink is only a 10 megahertz carrier as well. So it isn't one that's going to need as much power as you would for the video downlink, but it is something that I wanted to highlight. Now, one last quirk that I do want to mention on this module, and that is when you power this up without a goggles connected or a drone, there is a transmission from this module even when you power it up with nothing on. It is only on the 5 gigahertz band and it is only from that single antenna, but it does pulse between 2 different frequencies. I will pop it up on the screen so you can see it. It is something you should be aware of if you are intending to fly around other users. It doesn't do any transmission on the 5.2 side. It is only on the 5.8. The Avatar goggles actually do something like this already, although the Avatar goggles don't usually pulse on the frequencies. They usually stay on one frequency, whereas this module is jumping between 2 separate ones. It's always been the case on the Avatar system that the goggles or the ground side is the master, the air side is the slave. So in signal loss, it is always the goggles side, the ground station side that transmits, and that is the same here as well, because remember, to the drone, this is the ground side. To the goggles, this is the air side. So it's behaving basically the same. But if you were to power these 2 up on the ground, the goggles and the module, this would be transmitting and this would be transmitting. Whereas if you were to power up just this side, this would be transmitting, but this side wouldn't. Now, to be able to demo and test a device like this is quite complex simply because of the legalities around what this device allows, but I wanted to try and prove that it actually works. So I've come up with a pretty simple situation. We're going to test this by trying to fly around an area where I lose visual line of sight. This isn't because of distance, but it's simply because of landmass. So it is a test that's going to allow me to demonstrate that the relay actually works. Now, as for what your use case for this will be, that may be completely different, but what I wanted to prove is that it does make a difference, and that's what we're going to take a look at next. Now, to demonstrate this today, we're going to be using the CaddX GoFilm 20. It's a nice little quad. It's got small antennas on the back as well, and it's just going to be ideal for demonstrating the repeater. I've got that now mounted on a tripod. You can see it there. We've got our Express LRS gear down there as well. I've taped some batteries to it. It's a bit of an abomination, but it will be good enough for showing if this actually works as intended. Everything is mounted onto the tripod. Yes, it's a little bit jank in places. I had to put some tape around it to stop it rotating because my mount doesn't hold tight. You can see down there, we've got Express LRS. We've got the 868-900 and the 2.4 gigs area. We've got our batteries strapped on. And the whole idea of this is then to repeat the signal from the quad. We're going to be coming in from over there, and we're going to be coming around this bend and trying to fly up to there with all of that landmass in the middle. The first test we will do without the relay involved, and then the second test will be with the relay, and it should allow me to get quite a bit further. Now, just to show you from where I'm standing, it is over there by that boat. So that's where the relay is, and what I'm going to be doing is flying around through this mass. So there is a cliff edge there, it's all rock up to about that height there and mud. So we're going to come around this bend and we're going to use that relay to forward us around. Okay, so we're going to do the test. Now, I'm in angle mode for this, well, I don't think it's going to make my life any easier, but it is quite windy here today. We're in 25 milliwatts and we are not through the relay. So what we're going to do is very slowly just come along. I do have someone with me on this. I've just got to watch my dog doesn't try and take this out, and that's part of the reason I'm going so slowly. And what we're going to do is go up around the corner, and we're going to see how far we can go. The wind is kicking in. Oh, we are starting to lose the signal. Let's just keep going. Oh, I don't want height. Let's take the height down. Ooh, oh. You can see we're really struggling here. And yeah, we've gone. We've lost the signal. I literally cannot get around the corner without the relay. Now next, I did another couple of tests just to see what it was doing, and I did manage on one flight to get a little bit further with a matched power level to the relay. That is the minimum setting the relay allows, but I still wasn't really able to fly much further than about there. The fence is the limit. Okay, so this is the first test with the relay. We're going to go again. Still very windy here today, but what we're going to do is move forward. Now again, I'm going slowly because the quad is being followed. I'm doing this as a demonstration more than anything to show you how the relay works. Now we're going to come up around the corner. I'm in angle mode again, which I absolutely hate, but we're going to come up around the corner and have a look at what it behaves like. You can see already there is a dramatic difference in performance with the relay. Just a huge difference. I couldn't even get near here earlier. I'm gonna keep pushing on up. I can't see the images blocking a bit. Latency, there is a little bit of latency. I'm not really going to comment on if it's a lot or it's a little. We're just going to come up around here. And again, it's just to show you what you can do with the relay and actually just prove that it works. Because right now, I am right through all of that mass, that woodland, but it's not just woodland, it's ground, it's solid. There's a cliff edge around there. We are absolutely right around there. I don't want to go over to there because if I head over to there, right, I will be behind the repeater, and I don't want to do that. But let's just come over here, and I'm going to probably stuff it in acro in a minute because angle mode just feels all over the place. You guys can see there what that looks like. Just come down and just, oh, the wind. It is, for this aircraft, it is very windy today. And I've also got like no camera angle either. Again, I want to keep it flat. You can see the repeater there next to the boat. So that's what we're using. And I'm over there just around that corner. And again, let's just go up. And just completely different. The repeater absolutely works. There's zero question about that at all. We are repeating both the Express LRS signal as well as the video signal from Avatar. I'm going to get out of angle mode in a minute because it's just horrible. If I now take it low down, again, we're right behind all of that mass, and we're now using the repeater to fire the signal along. So yeah, it absolutely does its job. It really does. Ooh, we even managed to dodge that little branch there. Now, it's really hard for me to comment on latency I can see movement in the image. You know, it's not as clear as it would be normally. There is the sort of, just come still, you can sort of see the staggering effect in movement. It's cleared up nicely there, but in movement there is some staggering of it, sort of like the stepping of the compression. But I think for the intended use case of this, you know, this isn't, I think, going to be, oh, I want the best possible image quality all of the time. It's, I need to be able to see where I'm flying in a situation where I'm not able to maintain visual line of sight. That was close. Really caught the top of that rock. There's a lot of puddles around here. Okay, so I'm in acro mode this time, just to do a test again. I've also put the camera angle up a little bit more. I'm not getting battered so much by the wind now. So again, you can see I'm keeping it really low on purpose, just to demonstrate that the repeater is working. You are absolutely seeing some movement in the image. You are definitely getting some judder now and again. It's hard to judge on latency, I'm going to be honest. There's a bit. I'm not going to pretend there isn't. There absolutely is, especially at speed. But yeah, there's definitely a bit. It's going to be impossible for me to really give you a number on that latency or what that looks like. Let's go back. Ooh, I'm definitely feeling a bit there, but we made it through. So, but yeah, more than anything, this part was to prove that it works, and it absolutely does. You see it's there. So if this is something you're looking for, it does what it says on the tin. Now, as I mentioned in some of that flight footage, I could definitely feel the latency moving around. However, it's quite hard for me to pin down exactly what the latency was when flying in the real world. We can, though, test this on the bench. And what we're going to do in a second is just have a look at a chart that I've put together showing you the latency when the aircraft is bound to the goggles, and then the latency when the aircraft is bound to the relay and then sent on to the goggles. Now, here is the results of a fresh set of tests. On the left, we have the latency in low latency mode. This is the best case scenario via the relay. And on the right, you have the low latency mode directly between the aircraft and the goggles X. Now, starting with the left-hand chart, you can see we've got a first pixel of 40 milliseconds and then a full frame of 49 milliseconds. Now, my latency tests in this were actually very, very consistent. I was pretty much getting either 40 or 41 milliseconds every single test, and it was always coming out about 9 milliseconds more to the full frame. With regards to then testing it without the relay involved, we're getting 27 milliseconds to the first pixel and 36 milliseconds to the full frame. Now, this does sort of line up with what I was expecting. You basically got about a 13 millisecond increase in latency as a result of having the relay in the system. Now, just something to note on those charts is you may have seen that the latency number for the system between the Moonlight and the goggles was coming in 27 milliseconds and then 36. This is actually a little bit higher than the latency that I have seen in the past with the Avatar HD system. I have my latency charts on FPV Wiki. I want to do a bit more testing around this. I don't know if this is specific to the Goggles X and Moonlight or if there's been a bit of a shift in latency. I didn't quite see it come down as low as I have in the past with the same test setup. But what this test is reflective of the difference that the relay makes, but I'm not quite seeing the lower latency levels that I was seeing on Avatar when I first tested it. I don't think the moonlight added anything, but I could check that again in the future. What I would say though is, from a relay perspective, it's adding 13 milliseconds, but that is best case scenario. In flight, what I will say is there were absolutely periods where that latency moved dramatically. I found that I was getting very slow reaction to the aircraft. There were periods in the footage where I showed you I almost actually crashed. It seems to move around a bit. I think it would be absolutely fine in a fixed wing situation. I definitely don't think this is a unit that you're going to want to use in a race environment or anything like that. Again, it will be dependent on the signal, the situation, the scenario, but best case, about 13 milliseconds. Worst case, it's basically impossible for me to say, but what I would say is expect quite a penalty when the signal starts to drop. Okay, so let's just do a quick tear down on this to have a look exactly what is going on. Now, we do have internal images from this unit already. Someone has actually shared them a while ago. But rather than just show you them, we will have a bit of a look ourselves to see what has been done. And we will just try and explain what exactly is going on under the hood, because it is quite interesting from what I've seen. And it is the first device that I have actually seen that's like this. So there is some interesting things to be aware of. Now, the basics on this unit is that it is 2 transmitter receiver modules back to back. It basically is the same layout as 2 VRX modules inside. If I just show you, we've got heat sinks here, obviously, for the cooling on the main chipsets. There's then heatsink and a fan in the center, and then you can see our antenna ports over here, our antenna ports over here as well. What you've got is a main chipset and an RF section. So you've got a main chipset right here, which you can see down there, and another main chipset up that area there. Then you've got the main RF chipsets located underneath, and when you do look at it, it is, as I said, it basically is a back-to-back receiver module, and they've obviously used some custom firmware that helps to basically tell it to relay the signal from one to another. Now, I've undone those. That releases us from the back. So if I pop the back over, you can see that side of the PCB there. Not really a great deal to see. We've got a diode on the power input there for protection. So if you had any problems, there's also a 0 ohm resistor there. So that'll be for some protection as well. So that gives you an indication of what's going on. And then if I just adjust the antennas so I can flip this back down, we then got our heat sink. That is loose now that I've done that. So let me grab a tool just to see if we can pop this up. That definitely feels loose. So I'm guessing we're just getting grab from the thermal compound. Yes, we are. There we go. So then inside we have our 2 RF sections, our 2 main chipsets, our RAM chips. There looks to be a combined RAM-ROM down here, and then up here we have, looks to be a flash ROM chip, Wimbond flash style chip. It's actually really similar to the receiver module. If we just go in a bit closer, so there you can see it. Now, I'm not going to clean off these chips. They are exactly the same ICs as in the main Avatar system. There's no difference here. We can get one of these lids off, so we will do that on both of them and have a look at them in a second. But the basics are we have the main avatar chipset. But the easiest way to think about this is if you drew a line down the middle here, you've just got a mirrored setup other than here. So we've got the avatar chipset with a flash RAM chip, an avatar chipset with a RAM chip. There's a WinBond chip, and then there's either NAND storage or a combined one. We'll have to have a look at that under the microscope to see what that is. So you've got your main OS, and they're basically back-to-backing the modules. And one's coming in, feeding it through, out. One's coming in, feeding through and out. Because remember, it's got to do it both ways. So it's got to take video in from the 5.8 side, feed it along, and pass that back out on the 5.2 side. And it's got to take telemetry on the 5.2 side, feed it in, pass it along, and pass that back out on the 5.8 side. So it's doing it both ways. But yeah, really, it's quite simple, but it isn't, but it is, if that sort of makes sense. So let's pop off our cans and let's see if we can just have a look at the transmission system. I'm going to get under this one with my tweezers and pop the lids off the can. Just going to move that one over. Here we go. Here we are. I'm going to place that one over there so I know which side is which. There we go. So we have our two what look to be IE2000 chipsets. Are they the IE2000s? I think we might have to microscope this. And then we've got the RF front end. Now, there is something interesting here, but I need to check. So that's the 5.5 to 5.8 gig side as well. Okay. So there is a different PA setup on this than there is on the standard module. And I'm actually wondering, is this doing far more transmission than we've seen on the other module in the past? And then if I just pop that side off, you can see there. Actually, yeah, that is interesting. So we've got that one, that one, that one is the same, and that one's different. So I'm going to have money that that's the transmission antenna and their receive. And on this side, we've got two bigger ones and two smaller ones. That is really interesting. And it is a different design to what we've seen in the past. It's not dramatically different, but it is different. Okay, so to wrap this video up and share with you some thoughts. Now, with regards to the relay itself, I have one complaint. Actually, I have two complaints, but one complaint about the relay module itself. And that is the fact that CaddX used a silly connector for the power. Why it doesn't have an XT30 or an XT60 on the bottom, I do not know. You end up having to make a cable. It just seems unnecessarily complex. It would have been far nicer if they'd have just put an internal right-angled XT30 that you could just plug a battery straight into, and that would have been perfect. My second complaint is the fact that they don't ship you the antennas you need for your goggles with the unit. I'm still not clear on what their situation is around this, because they did say to me they don't have antennas yet, but they will be coming in the future, but I haven't received them, I haven't heard about them, I haven't seen them listed anywhere. The fact is, if you get this today, your goggles have 5.8 gigs antennas, yet they go onto a 5.2 gigs mode to communicate with this. It's not likely to cause damage to your goggles. I wouldn't worry about that. Sorry. It's not going to do anything that you need to worry about, but it's definitely going to reduce performance. And I had to use those in my tests. I wasn't in a situation where goggles antenna performance to the relay was tested. In this scenario, I was close enough that it simply wasn't a problem. But if you were looking to mount this on an aircraft and try to do like a maximum range situation, then your goggles antennas are definitely going to be an issue. With regards to who this product is for, that's complex. I don't think it's a product for a race environment or people who want the lowest latency. It's certainly a product that works. I am more than happy to say it relays the signal. I think there is going to be some interesting behavior around latency, as I've already shown, but it is a tool for a specific task, and I think it seems to do that well from my testing. And it's one of the only tools like this available on the market. So if you're in a situation where you want something like this, CaddX are giving it to you. DJI don't make anything like this for their FPV system. DJI do make a relay for 03 and 04 for their professional products, but they don't make it for FPV. So if you're someone that wanted this kind of thing, then yeah, it's there. Now, with regards to price, I'm not going to touch too much on that. It's on the CaddX website. It's expensive. It's not as expensive as I actually expected. I thought this would cost a lot more, actually. I think for what hardware is in it, it's not a terrible price, but it's certainly not a price for everyone. But I think it's not a price you could complain about. To complain about a price on a device like this seems just silly. It's a very low volume, very niche product that is only going to serve very specific use cases. And as a result of that, you're going to pay for it. What I do like is the fact that it is something different and it is a product that allows people to do things they wouldn't ordinarily be able to do. And that's a bit of the story of CaddX. And I'd love to be able to sit here and tell you more things like this, because CaddX have a real opportunity to release products like a HDMI input VTX for Avatar HD. People would love that. CaddX are in a position where they're able to deliver things the likes of DJI and others won't. And it's great to see a product like this for those who want it. I think we all probably know the kinds of situations that this is going to be used, but that doesn't mean there aren't legitimate use cases. I just wish we would see some development on other stuff as well, you know, like that HDMI VTX. But in the end, it does what it says on the tin, and there's nothing more to say other than that. Now, I want to thank CaddX for sending this over. Very, very interesting indeed. If you're interested in finding out more about the Goggles X, I will link to my review of those goggles in the description if you're interested in seeing it. And finally, I just want to say, if you have found this video interesting and you'd like to support the channel to allow me to keep making content like this, please do consider checking out the link to my Patreon or buy me a coffee. It is only through the support of my Patreons am I able to keep making content on this channel. And if you'd like to support us to allow us to keep making content in the future, please do consider checking it out. I want to say a huge thank you, and I honestly do mean this, a massive thank you to all my Patrons. We would not be able to do this without your support. Anyway, that's it from me on this one. Link in the description. Stay safe. I will speak to you soon.